This is homework set 36 on the logarithm function. Question 1 asks us to convert this exponential form to logarithmic form. So to do this, I'm just going to remember this. Logarithms are exponents. If you know this, you can probably do all of these problems. So here's what we have. 5 to the third is 125. Now, logarithms are exponents. So what's the exponent here? 3. So 3, I'm just going to write what I say. 3 is the exponent, but exponents are logarithms. 3 is the logarithm. Now what's the base here? The base of this exponential is 5. So base 5 of 125. And if you read it this way, the logarithm is the exponent. In question 2, let's convert this exponential form to logarithm form. So all I'm going to do here is remember that logarithms are exponents. So what's the exponent up here? The exponent is -4. So exponents are logarithms. So I'm going to write here that -4 is equal to the logarithm. Now what's the base? The base on this exponential is 10. Log base 10 of, now I'm going to put parentheses here, 0.1230 and a 1. And if I read it, it says the logarithm is the exponent. Question 3, here's another exponential form. Let's convert it to log form. So logarithms are exponents. The exponent here is -2. So -2, that's equal to the logarithm. What's the base? 5. The only other number here is 1 over 125. And what it says is that the logarithm, base 5, is the exponent. Question 4, same thing, convert this exponential form to logarithmic form. So over here, logarithms are exponents, and the exponent here is -2. So how about -2 is equal to the log. Now the base here is 1/5. I'll write it like this. 1/5 of, just so it's clear, I'll put the 25 in parentheses. You don't need to do that. But what it says is that the logarithm, base 1/5, is -2. There we go. Let's change it up now in question 5. Now we're given the logarithmic form, and we want to convert it to exponential form. So again, logarithms are exponents. So when I read this, the logarithm is, well, there's the exponent. So the logarithm is the exponent. So this exponent goes on a base, and the base is 10. So I'm going to write 10 to the 5th is equal to 100,000. Let's convert, in question 6, let's convert this logarithmic statement to an exponential statement. Logarithms are exponents, so the exponent is 6. Exponents go on bases, and the base is 2. So we're going to get 2 to the 6th is 64, and it's a true statement. 2 times 2 times 2, blah, 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 is 64. Question 7, this says that the logarithm base 8 of 1 is 0. Now, it's a true statement because you might remember that the logarithm, any base at all, of 1, the logarithm of 1, any base is 0. So let's convert it. The logarithm is the exponent. So the exponent is 0. Exponents go on bases. The base here is at 8, so we're going to have 8 to the 0 equals 1. And sure enough, 8 to the 0, any non-zero number to the 0 is 1. So there is question 7. Question 8, let's convert this logarithmic form to exponential form. Logarithms are exponents. The logarithm is the exponent. So the exponent is a 1. Exponents go on bases. The base is this 8 right here. That's the base right there. So let's write this as that base to the 1 is equal to 8. And sure enough, it's a true statement. Question 9, we're going to convert this logarithmic statement to an exponential statement. The logarithm is the exponent. Exponent is -5. It goes on that base, which is that 10. So how about 10 to the -5 is equal to 0. I see 4 zeros and a 1. Question 10. The logarithm base 6 of 36 is 2. This is a logarithmic form. Convert it to exponential form. the logarithm is the exponent. That exponent 2 will go on that base 6. 6 to the 2 equals 36, and sure enough, 6 squared is 36, so we've got it right. Question 11 gives us the logarithm base 5 of 1/25 equaling -2. So the logarithm is the exponent. Let's put that exponent on that base. So we'll get 5 to the -2 equals, the only number left is 1/25. And you know this is right, don't you? Because this is 1/5 to the +2, which is 1/25. So it does work. Well, in question 12, we want to solve this equation here for x. Now, I'm going to convert it to a more familiar form. I'm going to convert it from log form to exponential form. So I know that the logarithm is the exponent. So the exponent here is 4. It's going to go on that base. 2 to the 4th, that's equal to x. And 2 to the 4th, that's 16. So I'm going to say x is 16. Question 13, let's solve this equation for x. Now we've got the log base 2 of x equals -2. So the logarithm is the exponent. All right, so we will get this base here, 2, raised to that exponent, that power. So we'll get 2 to the -2, that's equal to x. But 2 to the -2, write that so that there's only positive exponents. Get rid of that negative exponent. So 1 over, just drop it into the base, into the denominator, that's x. And this is 1/4, that's equal to x. Question 14 asks us to solve this logarithm equation for x. So I know, of course, that logarithms are exponents. The logarithm is the exponent. So the exponents go on a base, and the base here is 2. So I'm converting this from logarithmic form to a more familiar form, exponential form. So 2 to the x, that is 1/16. Now, I've got to just try to think about what x is. So here's what I know. I know that 2 to the 4th, that's equal to 16. But now we've got this. I've got 1/16. So I would like this to be 1/2 to the 4th. Now we have 2 to the x, and I want to get this to be 1/2 to the 4th. So what I need to do is just get a negative exponent here. So how about x is -4? Because 2 to the -4 is 1/2 to the +4, which is 1/16. All right, so there's our x. X is -4. Question 15, let's solve this logarithmic equation for x. So the logarithm is the exponent. So the exponent's 3 is going to go on that base. So I'm going to have x to the 3rd is 64. And we just have to have some basic knowledge here. What number are you going to multiply by itself, but multiply 3 times to get 64? Well, it's not 1, it's not 2, right? 2 times 2 times 2, that's only 8. It's not 3. 3 times 3 times 3 is 27. But 4 works. 4 times 4 is 16. Times 4 again is 64. So I could put 4's in here. So I'm going to claim now that x is equal to 4. And that ends this part of homework set 36.